Hello everyone, welcome back to another tutorial. Today I will teach you how to import OpenStreetMap OSM data into Grasshopper and Rhino using the plugin Urbano. If you have perhaps seen my YouTube channel, I have a previous tutorial or video in which I show you how to import shapefiles, GIS shapefiles with Urbano. So this time we're going to do it with OpenStreetMap. So I recommend you to have a look at that tutorial because I explained the what it is Urbano, how to install the plugin, and how to start playing with the basic tools and components. Today we're gonna use this import OSM feature. So it's very easy and straightforward. In fact, this step. But before doing that, what we need to do is generate the OSM map. So we go to OpenStreetMap, we go to export and we select manually an area, and then we export it and save it. As you see here, I already done all these steps to speed up the process. If your area is too large, you have the risk of having problems and not being able to export because you have too many nodes. So the software will let you know. Now, another thing is important is that, as you can see, there are building footprints here in the area. This will depend, so the quality of your modeling, Rhino, will depend on the data that is here. If there is missing buildings, missing data, you have to contribute, log in, contribute, and digitize them, update the data, and then you will be able to have a most accurate map in Rhino. So let's go back to Rhino. And what we have here is first we need to create a file path. So we need to create a file path and connect it there. There's no problem. This file path should be, we set up one existing file and we go to where are our downloads. And then we have the North Adelaide map. And there we have the points. So what we need to do is I'm going to disable this preview because it's more important for me is just to create a polylines. We connect the vertices to those points and then we close the closed polyline. So is this true? It's false. So we can create closed polylines or open. In this case, we can set this boolean to true, or we can have also a boolean toggle. So once we have the polyline, now what we can do is try to create VREPs. So we can create footprints for this building. So we create a VREP and we connect the VREP there. That's good. So once we have created the VREP, then we can disable this. We're trying to simplify the version. And then we grab this VREP to make it easy for everyone, and we can extrude it on a particular direction. So we use extrude. Very simple connector. We need to define the direction, so we need a unit set, and we need to define the height for that direction. So what I'm going to do here is I'm going to disable this preview as well and only take the extrusion. And let's put 11 meters and connect them there. So it will take a bit, and then the volume should appear. They are already there. Okay, buildings. But this is a unique value. So all the buildings will have the same height, which is not in reality what's going on. So it's an option. And we can use a custom preview to color this in any way we want. Again, we disable. And then we choose a color swatch for that custom preview. I like the colors around the blues. It can be there. That's a nice color for buildings. Okay. Oh, dark color, it's good. Yeah. So we have them. So as you can see here, we have the volumes. Now we can bake them. If you want to bring them or export it as a shape or form into Rhino, then we just right click here. Sorry, we can click the scroll button in your mouse and then go and bake them. And then we'll go automatically to the default or any layer you choose. So you have them here and you can change the representation, let's say to shaded, or you can go for render. It will take a bit with render, but you can see here the volumes and wireframe. Okay, so we're gonna delete this because I'm not interested now in showing you how to export this. Okay, we have now our buildings. Now I want to know the real height of the building. So there is another option. We disable all of this. The other option is using something called in the model is like create building. So we have here the buildings, and we just connect the polylines as the building curves to these ones. And then again, you see them there. Then we use something called inspect building, which is here in the metadata, inspect building. And this building, of course, we need to use the metadata. So we need to connect the metadata here and then connect this building into this one. And as you can see, buildings have a specific height. The information is collected from the metadata. So now we have buildings better represented. And again, we can bake them. And so we're going to have buildings that are real with the real height. Okay, they look a bit over because we have these layers on. And we have to disable this layer. So you will have your buildings there. So that's how it is. And notice here, there are two buildings overlapping with each other. And this is happening because there are errors there, or is the previous, or is just the previous buildings that were there. And you need to double check these problems, okay? So what we're gonna do is now, or maybe the custom preview, I don't know, but there are duplicated buildings there, so we need to be careful with it, okay? We delete this. We don't need the buildings. Now we go to wireframe. Okay. So we turn on this and we have the buildings there with the height. Okay. This is another way. Now what we can do now is we can import the street network. Okay. So we make more interest in our model. So we import the OpenStreetMap street network. There are different options. Here you can choose the building in format, in feature, building amenity on a street. You can also go for a street and everything will be completely different. The rep didn't work because there is an arrow here. So it's a building. Or you can use the street here. You can create an amenity. You can choose among other features like boundaries, natural places, railways, public transport, so on, waterways. So what I'm going to build now is I want a street network. So again, I can connect this. Something that I haven't defined is the UTM, and it's another possibility. You can generate your indicate your UTM. For this, you need to use the text. You set up the text. Some cases you need the H. Some cases you need the 50, just the zone. So in this case, I use the 54 because that's the zone corresponding to Adelaide. Connect to the UTM zone. And then I double check here. Once it is this done, it's here. It's automatically identify the 54H. So I don't need to worry about it. You can import the altitude as well, which is useful if you want to generate, if you have a very steep topography. It's now thinking. Okay. So once we have done this, why? Because now it will be adapted everything to the topography, as you can see here. Okay. So we have the street network. Again, we can use the custom preview to show a different color for the street network. So I'm copying these two elements. I'm bringing here the street network. Where is the street network? Goes there to geometry. It seems that the street network doesn't represent very well. They not use the custom preview for some reason. Because here, what you have is you need the segments. So with the segments, yeah, it works properly, and we enable this, and then we can use a different color there, okay, for the street network. And again, you have a lot of information here. UTM is correct, and you can connect the translation vectors like previous in previous tutorial. But in this case, they are coming from the same path, but that's why you don't need to do it. But if you have information from, let's imagine another set OpenStreetMap file, you need to use the translation vector to connect, because otherwise one will be in different origins. Okay, so we already built here we already built a very simple model, and then we can add more complexity, adding other street network models. I want to show you something is what happens if we add the feature, which is a street. We use the same path, and we select here, instead of building a street, and again, we have to disable this. Again, we have to disable this. And once we have done this, we can copy also the UTM. As you can see, it was automatically generated here, the UTM, so it detected from the file. So there's not a problem. Let me save this. Remember the rule of saving all the time. So we have here again the points. What we can do is just create again another polyline, and we use these vertices. So, and we enable it. So you can identify here all the polyline has very funny shapes because we choose it closed. So we need to set the boolean to false, and then we will have open lines. As you can see, there are other lines there, extra lines that appear on the streets that they didn't appear in the street network. And that's the reason is because they have different, they are here, the component is reading a different information from the file. So the street network is used for other tools of the model, like simulating walkability or connections. So it's based on connectivity. Meanwhile, this one, streets, are only showing the polylines, the lines corresponding to the streets. So depending what you're going to use this information for, you need to use either one method or another method. Okay. So another thing that I wanted to show you quickly is, let me turn off this. Let me bring this one here. It's that we can, like we build a model, we can create a street network. And again, we can connect the streets from either these points. I think it doesn't work. We need a polyline, again, polyline. So we can connect here vertices and then there. So we disable this. And then we are going to need the metadata that comes from here, from the streets, or from this one. It doesn't matter. We need to choose if we want to split street curves. We need the UTM zone from here, and any translation vector from this one as well. So now it's somehow working, and you build a street network. And we can also connect these street segment curves here directly without connecting this one. So you can see we build the street network. Now, what I want to do is just like with this, we can build a model. And then so it's that build Urbano model. And the Urbano model requires this street network, require the buildings. Okay. So the model is a unified model. It's a whole model that will toggle, it will build it. So let me disconnect this for a moment and just stick to this. As you see, is the model shows a null because I haven't used this toggle and turn it on. So I click there, so it built the model. So once the model is built, it has a lot of information in this model. So it's extracted and you can use it for other purposes like simulations or finding streets and finding short paths, etc. So we go here, and as you can see, if you go to the buildings, it will automatically generate the buildings again with the heights. you can use a default height. In this case, it's using the information from the metadata. So that's why. Geometries are curves, are not buildings, but you also have building meshes. So you can export all this information, right? So what we have here now is just the buildings. We have the street network as well. So we are building and adding complexity to the model. Now, if you want to visualize the buildings, if you use this geometry to create a custom preview, this is what is going to happen. Let me grab the custom preview from here. Let me change the color to make it much lighter. And if we connect this geometry, where you're going to visualize, we need to disable this. And enable this one. So what you're going to visualize are the geometry which are polylines. Okay, you don't see the volume. If you want to see the volume, you need to use the mesh, the building mesh. And for that, you need to just use mesh. So it's different because the previous one is a vrep from the polyline. That's what extruded. And here is just you get the mesh. And from the mesh, you connect to the geometry. And then is when you see the geometries of the buildings, the volumes of the buildings, sorry, properly represented for that site. Correct? Let me reduce this a bit. So that's basically what we how we build and we add complexity to our model, and then we can create we can add other information here, like for example the features like water ways, or we can identify power, geological boundaries, or public transport or waterways. Let's see if there is more information there. It's not very difficult to do this. We just got, yes, there are waterways there, as you can see. So we just disable this. And again, we copy this polyline, we connect it, and from the polyline, we create a custom preview. So it's more logical that the streets should have another color, right? So we can go for another color for the streets, maybe orange color. Okay. Oh, sorry, the street network is here. So let's come here, and we could, yeah, that could be an interesting color, yeah. And so we copy this. Let's grab this, drag it and Alt, and then connect the polyline. And then this one should be blue. Again, they are closed, so we need to set this boolean to false. So you see the waterways there. Buildings, perhaps this is also not the best color. We need to use more, you can use a reddish color or a greenish, or this is good. So as you can see it here, you start building more and more information. There are some problems here because obviously these lines were built manually and some of them are just polylines not properly closed. But once you bake them, you can clean them. That's a problem with the geometries. Okay. And finally, the last thing I want to show you is another component called download DM and build terrain mesh. So this tool, very simple as well. You need to define bounds, and for those bounds, we are going to open a panel. We're going to make 4 copies. Okay. Yeah. And where you get that information? That information comes from here. So this is the left bound. Go back to, so this is the left bound. Okay. Now we go to the right bound. Correct. Then we go to the top bound. Top bound. And finally, we go to the bottom bound. Bottom bound here. So we now connect these ones. This information, and then it will take a bit and it will generate a mesh. This particular terrain is relatively flat, so I recommend you to do some trials in other places if there is not flat, but it is what it is. And so the DM in this case was built. Look, um, it's gonna get the information here. Okay, the terrain building in this case was constructed using the USGS, the American Geological United States Geological Service, using an OSRTM3 um, DEM information. Okay, basically it's just the worldwide available DEMs, um, which is generally 30 meters. Is one arc second. Spatial resolution, which is approximately 30 meters. It's 29.9 something. So then is when you have the terrain, and again, if you want to create a terrain mesh from this is the terrain mesh. You turn off this, and then you can bake again the terrain into a Grasshopper. So you have here. You have again information of the UTM is the same translation vector. All of them have the same translation vector because they're all coming from the same file and the same bounds. You change the bounds or the sizes, then you have to use and connect them some way, one with each other. But it's not the case. So I just wanted to show you quickly here how you can create a basic model from OpenStreetMap in Rhino and Grasshopper. And I hope this is very useful for you. Let me just disable this custom preview and then use finally a geometry here. Let me save this, and of course I want a sort of much nicer background there, and that's it. So I hope this is very useful for you, and in the next tutorial we'll try to teach more tools in following tutorials, more tools on Urbano, how to import also LiDAR, but that will be in future. And thank you so much for your attention, and see you next time. Bye bye.